I think they're online. Online.
Okay, so can you do English? I need to stay here. So, hi, my name is Jardan Samek, and I work here for a couple of years. And on our project, we use Amazon Web Services for quite a while. So I want to tell you something about it, why I think you can benefit from that, and why you should use it maybe. So first we start with some survey time. So is anyone using Amazon Web Services? One, two, maybe few. Production use, or is it just testing, development tool?
We migrated to on DMA. We migrated to Deutsche Telekom, but before we used AWS.
Azure, anyone? Microsoft Azure? Maybe not many .NET developers here. Okay, so Google Cloud Platform, anyone? Nothing. DigitalOcean?
I think Google is used for Okana. But I'm not sure.
Yeah, DigitalOcean mobile. Okay, so
I will go busy here, and you should talk more louder, please.
okay. So what the cloud actually is? I didn't know either, so I put it in Google, and he came out with this cloud computing. Cloud computing is general term for the delivery of services over the internet, which is, I think, accurate. Usually you hear shortcuts like IaaS, infrastructure as a service, platform as a service, and others even service as a service, which is a bit strange, but makes sense in some cases. But basically the idea is to treat the data centers and the infrastructure more like a utility. So, for example, same as electricity. You don't care how the electricity got into your plug, but it's there, and you can always use it. You can put chainsaw in there, which has high demand for electricity, or your mobile phone charger, which has low demand for the charge. And it doesn't care what you put in the plug. Okay. So what are the typical properties for the cloud? It's the main thing is flexibility. You can have low workload and high workload, and you can change it. So you can have smaller infrastructure during nights and, for example, weekends, and a larger infrastructure with more servers, more compute capacity over, I don't know, Christmas or where you actually need it. And you usually pay only for what you actually use. So if you use low workload, you pay much less than as when you use a lot of servers, a lot of memory, and a lot of space. It could be cheaper, but it strongly depends on your use case. If you use cloud, it doesn't immediately mean it will be cheaper, but it usually is, but it's not guaranteed. The main, it's not the number one property. From my experience, the number one property of cloud is the flexibility. And what is also great about cloud computing is you can easily experiment and experiment for very low cost. So, for example, I was evaluating different database settings. So I just ran over and over the same server with different properties. I put a benchmark on the database, and that way I was able to test 20 or maybe 50 different configurations and evaluate which one is best suited for my use case. And it can be done very cheaply. We only pay a few dollars for all these home testing with huge servers with many CPUs and a lot of memory. So maybe it comes not as fast with many of modern services actually use Amazon Web Services. For example, Netflix is the most famous user of the Amazon Web Services, but also Airbnb. And if you have Spotify subscription and you listen to music, the music is actually streamed from Amazon storage, or maybe more specifically from the cloud from Amazon CDN. But AWS is also used by Slack or purposes. So this is how the infrastructure of Amazon Web Services looks like. They have these groups, data centers, which is called regions. So they have, for example, Singapore region, and total of 13, I think. But a lot of them are in preparation. So we mentioned to have London region, and in all these regions, in Europe we have Ireland, which is the oldest one in Europe. Now we have Frankfurt, which was launched in 2014, and London might be coming soon, or not, depends. In each region, there are availability zones. You can imagine availability zone as the separate data center. So in each region, there are at least two completely separated data centers, which have different in different buildings. They are not apart. For example, for disasters like flooding or meteors and stuff like that. They have redundant power, and they are connected to different power, I don't know how it's called, circuits or power networks. And they have different networking and connectivity providers, and all is redundant. And they also have a very strong connection between each other. So the replication in between the availability zones in the same region is really fast and really low latency. Also important, if you plan to have your application highly available, then you should design it in the way that it runs in at least two availability zones. Because Amazon doesn't give you any guarantee about he gives you some guarantee about the accessibility of the certain availability zone, but for the high availability, you should always have it in two separate availability zones and have something above it which routes the traffic to the run of the second, and which has some kind of health check, so it checks if the availability zone is available or not. And if you have the application in at least two these availability zones, that it is highly available. Yeah. They also have something which is called edge locations. These edge locations are typically smaller data centers, and they only run two services. And it is a DNS service, because DNS is nowadays very important because of a lot of services use DNS failover. And also, if you don't get the IP address for your domain entry, then the customer won't be able to communicate with you regardless of how the status of your application is or isn't. And also, CloudFront is provided from edge locations, which is Amazon's content delivery network. So if you put your static resources in this CloudFront, then would you actually use that your application or your static resources can run from 70 different locations all around the globe, and that way each customer can get this data with very low latency and really fast. Maybe something which would be interesting for us. The closest to us are Warsaw and Frankfurt. no actual caching in check currently. Also, what is really great about Amazon Web Services is that it offers so-called free tier, which I usually refer as free year. It means that you can test most of the AWS services for free, usually for 12 months, but some of them even longer. Some of them are without time constraint. So you can see. So for example, Amazon EC2, which is this infrastructure as a service service. You can run this small machine with one CPU and 1 GB of RAM for a whole month, each month for whole year basically. You can have 5 gigabytes of storage in S3, and also many more services, which I will talk about some of them later in my presentation. So basically, all of this, not every single service, but most of them can be tested for free. So I will talk about some of them. First of them is Amazon S3, or Simple Storage Service, which is why it's S3. It's designed. It's storage service, and it's designed for really high durability. So it has like 11 nines durability. So they basically claiming that they will lose your data. It's available by default. It's highly scalable. How much data you store, that performance you basically get. It's quite cheap. It's only usually 3 cents per gigabyte. And it also can be used very easily for static website hosting. And you can get some really nice features. So like it has optional versioning. So if you put a new version of your application or static resources, you can easily get back to the old one. And it's connected to another Amazon service, which is Amazon Glacier, and it's used for archiving. And using this Amazon Glacier, you can get even lower cost per gigabyte stored, which is about, I think, $7 US for 1 terabyte storage. But it's used only for archiving. You cannot easily access that. Because if you want to access something, then you need to request this from Amazon, and they have usually a couple of 1 or 2 hours before they retrieve it and you can download it. So it's great for archiving, but not so great for if you actually need the data immediately accessible. I already talked a bit about Amazon CloudFront, which is content delivery network. It runs on these edge locations, which are more than 70 around the world. And it's used basically, it's content delivery network. So it's for static files delivery and also for multimedia streaming. It's connected to the S3. So if you put anything to your S3 bucket, then it can be, if you switch it on, it can be accessible through this CDN network. And it's actually cheaper to use Amazon CloudFront for static HTTP access than direct HTTP access to your S3 bucket. So that way they motivate you to actually use this content delivery network instead of this static hosting of S3. Another famous service, most known to most people, is EC2, which is virtual server hosting. So you can launch a new virtual server. It has different types of virtual servers. General purpose, which has these ideal balance between number of CPUs, number of memory CPU and memory. Then there are computer optimized instances which have more CPUs than memory. Memory optimized for which have more memory and CPU. You get the idea. For example, these memory optimized machines are usually used for database. Then they have CPU instances which have some kind of NVIDIA, Tesla GPU. And also they have storage optimized instances which have very high I/O for these for internal hard drive, and they also have dense storage optimized machines which can be used for I don't know, data mining. They have really large hard drives. Amazon RDS. It's again quite known. It's basically managed relation database. You can choose from Postgres, MySQL, Maria, Oracle, or Microsoft SQL Server. And they also have Amazon Aurora, which is their own. It's it's not really fork of MySQL. It's their own built relation database. But it uses the same tools as MySQL, so it uses MySQL connectors and is compatible on this connection layer with MySQL. So it's easy for the developers to migrate from MySQL to this Amazon Aurora, which was designed from scratch to their actual infrastructure, and it's for the performance is the cheapest option they offer. So it's very performant, and yeah, maybe if you are until now using MySQL, it's worth have a look on this Amazon Aurora, which is really great and has really high performance. These relation databases can be highly available if you choose this highly available mode. In this case, they run two same databases, and they have synchronous replica between them. So if one goes down, they immediately replace it with his replica, and that way you never even experience any trouble in ideal case. They also take care of the backups, and they offer point-in-time recovery. And it is even if it is a managed database, it's highly configurable. So, for example, in Postgres, you can specify how many memory it should use per connection, or how many connections it will allow for the database, and you can fine-tune it for your use case, because different application needs different settings. Someone uses a lot of connections with low demands per memory per connection, but someone uses rather small number of connections but requires larger memory because they do more aggregations, etc. Another interesting service, Amazon Lambda. As a service, or it's somewhere called service architecture. It's basically something similar to platform as a service. So you just upload your application, but in this case, you only upload just one small function which reacts to specific event. So there is no need to specify how many memory you specify how many memory, sorry, how many CPUs you use, or on how many instances it should run. You don't need to specify these scaling parameters and stuff like that. So it is continuously scaling up and down as needed, and you are only charged for the actual CPU time it consumes. So you don't need to manage any server or any settings. Like if you use something like Heroku or Beanstalk, then you always need to specify how the performance will look like, how it will scale up or down. In this case, you don't even need to do that. So it is a little bit far beyond this platform as a service. Okay, Amazon CloudFormation, another interesting service. It basically allows you to specify your infrastructure in Amazon AWS as a code. So it looks like it's JSON-like format, and you specify your whole infrastructure in this JSON, and then you just push one button and it will prepare the whole infrastructure. And if you need to change something small, like different security options, you will change just these options and just do rebuild, and it will incrementally just change what is necessary. So it's really nice tool. And again, to have the infrastructure as a code is another benefit, because then you can put it in your version control, and you as a developer can specify how memory it should have, how many CPUs. If you introduce new feature which requires more CPU, then you just simply add a different instance type to your server, and it runs smoothly. Another service which could be interesting for you, Amazon AWS provides free Git repositories. So if you have some personal project which you don't want to share on, for example, GitHub, because on GitHub is either publicly accessible or you need to pay for that. With Code Commit, you can have up to 50 gigabytes of Git storage and up to 5 users and 10,000 Git requests per month, which should be enough for even small things.
It's only one repository, right?
But we need to meet these requirements. I'm not sure. We can look later for that. Another interesting service is Amazon Doing 53. It's managed DNS. And does anybody know why it's 53? What the number means? No. 53 is the port which used by DNS. So it's why it's route 53. It's highly available by default because it runs on all these 70 edge locations. And Amazon realized soon enough that DNS is very important for the customers, because if you don't have, if you can't resolve the DNS, the domain name for the DNS, then your customer cannot get their application if it runs smoothly. So it's highly available. It has integrated health checks. It can have latency-based routing. The routing can be based on geolocations, so you can specify the customers from Europe will get one IP address, the customers from USA will get another IP address. And there are a lot of options. And I even heard that many of AWS customers use only this Route 53 because of this high availability and really nice features. They don't use anything else. They use only this Route 53. And then they have the rest of the stuff in their own data center. I can talk here about these different services for hours because there are a lot of them. They have, for example, managed machine learning. So you don't have to be a data science engineer to use machine learning. They have many mobile development services like Cognito, and even this device farm, which is a way how to test up your application on many devices. You just specify automated tests and on your mobile application, and then they run it on various type of devices, and they record each session on camera. So if anything broke on, for example, Galaxy S7 Edge, then you can see what was broken, why it didn't work, etc. They have also support for Internet of Things. They have data warehouse as a service, Hadoop as a service. They even have support for game developers, and many tools for analytics. What I'm basically trying to tell you is that they have so many things you can benefit from. You should always invest some time if you're running a new project and and to see what all the things you can use, and then maybe to design it just for it, because then you can get really nice performance for really low cost, because all these other services are usually quite low cost. Okay, so I just that was all from the slides, and now I want to show you some demo. Okay. Okay, how many time do we have? Oh. Okay. Okay. So I will definitely show you how the console looks like. So this is what you will see when you connect to AWS. These are all the services you can use. And to not waste your time, I will just show you how to simply launch a new EC2 instance, which is the server. If you go to EC2, then there is launch instance. It's quite easy. You will just select what you want to use. Here are some images for quick start, but they have something which is called AWS Marketplace, and there are many third parties offering their images. Some of them are paid, some of them are not. So if we try to launch this Ubuntu server, on the other page, you will just select how large your instance should be. So this one free-tier eligible is this one CPU, 1 GB, but you can go up to, I think the largest instance has something like 128 CPUs and 2 TB of RAM. So I think it should fit to anybody. On the other page, we will just specify some of the basically networking settings. If you want to have public IP address or not, you can either place your instance in private network, and you will need to have another instance which has public access to access it, and you can add storage. Again, you can specify how many do you need. All the time when I want some virtual machine from Ben, and I ask him for 200 GB, he tells me, "Why so many? 100?" And he always is negotiating for lower amount of gigabytes. Okay, so maybe we can start with 30, and we will just specify the name of your machine. So let's say Ubuntu test. Now you just specify these security groups. These security groups are networking firewall, but it's managed by hypervisor, not by the instance. Because if you have this firewall in instance, it can be tampered with. But this one doesn't have any relation to the instance. So if someone breaks to your instance, he cannot tamper with this. So we can just let's open it to the whole internet and just review and launch. And if we are launching Linux-based instance, we need to provide, either we provide existing key pair, which we already have, our SSH public key, or Amazon can even generate one for us. So into test, we will download it, and now we can launch it. It will take some time, like a minute or so, and the instance will be running. And now specifying the path to the downloaded I call it Ubuntu test to the downloaded key, and now I just need to have IP address for the server, which we can get here, public IP. We trust this one. Come on. Now we are on the server, and so we can, for example, install Apache. Or, I don't know, MySQL. Yeah, .NET framework. MySQL is MySQL. Now it's called server. Okay, and now, okay. Now the loophole, you need to always run sudo apt-get update to retrieve the latest packages, and yeah, that way you can do anything like on the proper virtual machine. Over. Oh, okay. Apache and MySQL server are installing, and we can have this LAMP stack running in a few minutes. Okay. That's all from my side. Do you have any questions? Anyone considering using AWS now? It's great. It can be a bit complicated from start, but yeah, you can get around it with some tutorials. They have really nice webinars. Really, the documentation is really nice, and you can get a lot of answers online, because AWS is the world's largest cloud service provider. It's larger than Azure, larger than Google Cloud Platform, and larger than the DigitalOcean. And I think it's even larger than all of three others combined. So a lot of materials are online.
And the pricing is set based on the combination of amount of gigabytes of storage, amount of CPUs, amount of memory. So it's like basically that you have got some.
So traffic.
Oh yeah, and you basically have got let's say as you have got this 3 cents per gigabyte, you have got some amount of money for CPU, and then basically the combination. It's not like a package system that you will have only this package, and if you want something in the middle, you cannot, because you can have either this amount of storage and then the another one is double. You basically combine exactly what you want.
You basically are paying in this EC2 world. You are basically paying for the instance. So the instance have, for example, the one that we just ran has one CPU and 1 gigabyte, and it is pricing something like $8 per month.
Instance we pay for is exactly the amount of CPUs. You pay for the amount of storage. You pay basically there's a cost for CPU, cost for storage.
Yes, there's price for storage, but you pay for instance. This is the CPU and memory combined,
Yeah,
basically.
and choose, right? You can have also paid instance when it's up only, and
You are paying only for the instance is up. If you shut it down, you are not paying. And also, if you need some storage, which you usually do, because you need to boot from something, then you also pay for this storage, which is separate. It's actually a separate service because this is EC2 and the storage is EBS, Elastic Block Storage, I think.
Combination of like buying some package together with some, for example, storage you're buying them according to what you need after what you want.
They have a calculator where you can actually predict, and then they have the estimation of the cost throughout the month. So even in the beginning of the month, you see approximately where you will end up.
If you go to billing and cost management, see how much I'm paying. I registered some domain, which is why I'm not paying zero. Otherwise, I would be paying zero. But I bought some domains, so I'm paying $40, I think. Yeah, here you can even set budget alarms, so you can get notified if you exceed something. And the prices are not final. So if you are running this instance and you are for sure will be running this instance for another year, you can get a reserved instance storage. And if you reserve this instance for a year, then yeah, you will get some discount. But always depends on your use case. If they have even something which is called spot instances, and that way you can get 90% discount for the instance. So you can have really large machine for 10% of the cost. But you need to set some. That way they only sell per computation power they have. So they will give you the instance if you basically you will say, I'm willing to pay $1 for this instance. And if their actual price, which is fluctuating up and down based on their load of the whole data center, if your price is above this fluctuation, they will run the instance. But if the price goes up, they will shut down the instance. So this can be used, for example, for some kind of batch processing. You just need to be online. There are a lot of these details which can be fine-tuned, and yeah. Or you can only run these. That you can scale number of your servers up and down, and you can even first try to scale up with these spot instances, which are really cheap. And then if it's not successful because the price of these spot instances went up, then you can run your proper instance for the whole price. So they have this really a lot of these options how to save a lot of money. Right.
How many policies are using it here in CM? How many policies are using the Amazon service in CM except payroll?
No.
Number of
Usually customers are using that. And sometimes using just to run the CI, for example, Jenkins or and stuff like this. It depends. The good thing is that with a small team, the customer can get the free tier for all this supporting stuff, CI, and so on. You don't need really powerful machines for that. You can easily run a year for free. The only cost we have, for example, Beaver is related to public IPs, so that we don't always need to monitor that IP has changed. And that's, I don't know, $10 per month, something like that. It's pretty cheap.
Okay. Any question? No. Okay. So.
Thanks.